Hi, I'm Chet Haas, an engineer on the Android team at Google. Today I wanted to talk a little bit about bitmaps. In particular, I want to talk about bitmap scaling. One of the big problems that people run into when running applications on constrained devices is that they want to load in, let's say, huge images from the camera on the phone, from the web, wherever. And when they're loading in a lot of these things, A, they're going to take a long time to come in, B, they're going to create garbage along the way and performance problems, and C, maybe they're going to run out of memory if they try to load too many at the same time. There are various ways of dealing with this situation. The overarching idea is that you should load and create and use the images of the size you need. So for example, don't load in an image that's this big if you're always going to display it as a thumbnail. Instead, load in whatever you need to, get it at the size you need it, and then have that be the image that you retain. So today's example is around loading in a scaled version of it. In particular, we're going to use a parameter in Bitmap factory options, which is called in sample size. So first, let's take a look at the demo. Which is called Bitmap scaling. And there's nothing to interact with here. I just wanted to show a visual representation of what's going on with these images, because there's something a little unobvious about in sample size the first time you use it. So the original image you can see up at the top under the words that say original image. And then you can see these scaled versions down below where it says scaled images. So we see 2 of the same size, and then 4 of the same size, and then 2 of the same size under there. So what's going on? Let's take a look at the code. So we have this class called Bitmap scaling. We have this image view where we're going to find the original image. We're going to decode the jelly bean statue image in there. And then we're going to add scaled image views. And this is going to be using the in sample size thing. So we're basically going to iterate from values from 2 to 10 and use that as our in sample size value and see what effect we get. So we create one of these bitmap options objects, and we set the in sample size to the sample size that was passed in, which is that integer value from 2 to 10. And then we create a scaled bitmap, which does a decode on that original image, but it uses the options. It uses this in sample size. And what in sample size tells it is how many pixels to read for each of the original pixels in the image. The advantage of doing it this way is that it reads less data. It's going to be faster to do this because it's basically skipping a lot of data along the way, potentially based on the value of in sample size. The disadvantage of doing it is that it's basically going to wind up with powers of 2 scales of your original image. So you can pass in a value of 2, which means it's going to skip every other pixel, and you're going to wind up with an image that's half the size of the original. If you ask for 3, it's happy to do that, except it doesn't really make sense. It's actually going to round down to the next lowest power of 2, and it's going to be equivalent to 2, which is why we see for the first 2 scaled images, they're exactly the same size, because passing in 3 was equivalent to passing in 2. When we go up to 4, that's the next power of 2. Okay, it's happy to do that. When we go up to 5, it rounds down to 4. So basically, in sample size is a very coarse-grained way of getting a scaled image. It works great in the cases where you want powers of 2 scales of your original image. Maybe it works for you to read in at that lower size, and you get a faster reading time because you're reading less data. But then once you have that data, maybe you then want to scale to the exact size that you want. And you can always get a bitmap of the exact size that you want through various mechanisms, creating it exactly at the width height that you want, or create a scaled bitmap. There's an API to create a scaled bitmap from another one. So there's lots of different ways to do that. Today was about using in sample size in particular. Higher performance because it reads less data, with the constraint that it will end up with powers of 2 images at the end. So in sample size, use it. Thanks.